Alright, welcome back. This stream is a new stream where we'll be solving some of the DSA questions on Leetcode. So if you can see here, this is my account and I've pretty much solved about 20, 30, 30 questions here in the last couple of days, and I'm looking to uh, solve the rest of it on stream, so that you can see, you can participate, and we can do it together. All right, so what we'll do is we'll just go by the easy ones first, get a catch of what's happening. All right, and then we'll go about with the medium one and the hard ones. So let me just start with the easy ones. Search insert position. So I believe this is something to do with arrays. All right, here's the question. It's an easy one. It's question number 35. Search insert position. Given sorted array of distinct integers and a target value, return the index of the target where the target is found. If not, return the index where it would be if it were inserted in order. You must write an algorithm with an order of log n, runtime complexity. Right, so for example, we have got 1356. We have to return where is 5, target is 5. 5 is at index 2, so we are going to return 2. In the second example, 1356, you can see the order is an increasing order, it's an ascending order, and we have to look for 2, and it's saying that 2 you would find at between 3 and 1. Okay, so it's not there in the array already, but if it were, it would have been at the place of 1, where 3 is currently. 3 would be at index 2, 5 would be at index 3, and 6 would be at index 4 if it were there. Okay, so you can understand. So it's a sorted array, and you have to find the position. Okay, this is a very small array in this example here, and so we are not going to be using that. We are going to assume it's going to be a very big array. If you had to do this in order of n, or in a brute force manner, all I would go is go from left to right. Okay, or right to left, whatever is comfortable, but I would go from, for example, go left to right and just see where just compare the current number uh, by the target, and at any point I find that the current number is greater than the target, okay, or equal to target, that is the index I want to return. Okay, that would be the brute force method. I'll just try and run it, and let's see. Okay, so I'll just increase the font here so that you guys are able to see it properly. Okay, so this is the font, something around 150, 125. Okay, search insert. So what I would simply do is for let I is equal to 0, I less than nums dot length I plus plus. Remember, this is going to give us a time complexity of order of n and not log n. So this is the brute force method, where we are going to be looking at the log n methodology also, and after this. But let's uh, begin with a simple brute force method. So what I'll do is, if target is less than or equal to nums at index I. Okay, if I get this, I'll just return this immediately. Return I. That's what I'll do. Let's run the code and see. It's a simple 2-line code, and it's working with the example. Let me submit and see. It's not working for 1357. They're looking for 7. Yeah, the output of course is undefined and expected was 4. So it fails in edge cases where I've already completed and there is no I've already completed the for loop and nothing is being returned from the array, right? Because 7 was expected to be the last, and so this line never gets executed at all. So in that case, I'll just to cover this edge case, I'll type return nums sorry nums dot length, right? I'll just return nums dot length. Let's run the code. It should be working here with the example. Perfect, accepted. Let's run the code for rest of the test cases. Perfect, everything is working. It's 60%, almost like 60% faster than the rest. Space, it's taking a lot of space. I don't know where, just with this I. Okay, so but this is not something we'll be happy with, because this is not order of n log n, sorry, not order of log n, this is order of n. Let's look at it in order of log n. So to get this working at order of log n, we need to make use of binary search, assuming this array to be huge. Okay, 10,000 numbers. If you go on doing one digit at a time, one number, one index at a time, it would take forever, right? If say your number is at the end of the array, it would take forever. Since it is a sorted array, binary search would work great here, right? Binary search, what it does is it divides, looks at the center element, and decides which half to let go, first half or second half. If say there are 10,000 number and the center number is 5,000, okay, and the target that I'm looking for is 3,000. So I just look at the center number, it's 5,000. It's not going to be, target is not going to be in the second half of the array at all, because it is sorted. It is only going to be in the first half of the array. So I'll discard the second half, I'll look into the first half, I'll divide the first half again into 2. This time I'm getting the center number as 2500, and I know the first half of this array, new array, is of no use to me. The number is definitely into the second half of this new array, and so on. I keep on doing this until I find the number. So that's what we're going to do. We're going to cut this off. Okay, this is not the solution we were looking for. What we'll do is, well, how do we cut, how long do we cut? Okay, this will also require, maybe it will also require recursion, right? um, can we do it in recursion, or can we do it with just with a while loop? Let's see, let's try it with a while loop. Okay, while uh, I'll just pass in let I is equal to 0. Okay, the start of the index, and let's keep it as s. Okay, s is the start index of the array, and let e be the end index of the array, which is nums dot length minus 1. Okay, so these are the two indices between which we need to find out. Okay, while e minus s, okay, length of the array, that length of the array that we're considering is less than less than 2, right? It could be either 1 or 0. Okay, if it is not found at all, it is going to be 0, right? So it could be 0, and if it is found, it is going to be 1, even with 1 we will have to check. So if it is less than 1, okay, in that case, while this is less than 1, we'll keep on going it, okay, and then finally we'll just return uh, 0, return start index, which is s, right? Okay, and now in this while loop, after this we'll also see how can this be done with a recursion, but let's begin with the while loop, right? Every function which is just a for loop or just a while loop can be converted into a recursion. All right, so we will see that as well. So in this while loop, what is the condition we are checking? We need to update start index and end index. So we will check the middle one. Okay, let's divide uh, e minus s, right? Let's divide. Let the difference is equal to e minus s. Okay, we are going to be using this quite a lot, and that is why I'm storing it in a variable. So if difference divided by 2, okay, and I need to mat dot floor this one because it could be an odd number, and that would give us index with a floating point number, and that is something that we do not want, right? So we're going to floor it because there couldn't be an index. We cannot search index with a floating point. Okay, we need an absolute number. Okay, so I can simply use mat.floor, or I could also use maybe mat.abs. No, absolute is to convert negative to positive, right? So what I'll do is mat.floor, okay, and if mat.floor, okay, mat.floor, I'll just introduce another index. I'll just mid, right? Mid index, midi. Okay, if mid index is equal to this one, okay, if I need to shorten this, can I do this? If nums at mid index is equal to, right, this will not come in here, this will come in the if block, is equal to target, right, will return mid index, right? Else if it is not, else if target greater than is greater than nums at mid index, okay, the number at mid index, in that case I'll just discard the first half, set the start index to be mid index plus 1, right, because it's definitely not the mid index, so I'll just keep it to plus 1, right? And else the only other condition remains is the target is less than number at mid index. So in that case, I'll discard the second half and set end index to be uh, mid index minus 1, right? Okay, so and then I'll calculate difference again after this. Difference is equal to E minus S. All right. So let's see what's happening here. Only in case of if the target is found, it's returning MIDI. There will be a situation, right, when the target is not found. Okay, and that's the what we call as edge case, right? Not actually edge case, it's not there in the array. Okay, and we are at that position where the difference is less than, okay, we have just mentioned it, return start index. If nothing found, just return start index. Let's run and see. It will definitely give us some errors. For this kind of a situation, what I do is I use a ripple, right? So let's go and use some ripple here. That will help us to ripple.it. That will help us to get things going for us. Okay, it will just help us to debug what is going on. Creating ripple node. Okay, create a ripple. Let's go ahead and create a ripple. A ripple is nothing but it is what do we call it, a sandbox where you can search insert. So I can do this. I can pass in my array 1 comma 2 comma 3 comma 4 comma 5 comma 6 comma 7 comma 8 and target to be 5. Okay, and just see what's happening, right? With a few console logs I can see. If I don't want to use deep console log but a debugger, I can do that on a separate file of Node.js or within the browser. Ripple, I don't think it gives you that kind of functionality as of now. But yeah, let's look at it. Let's run this. Let's see what do we get. We got 0. We got 0, so we'll put up some we'll put up some logs where we'll check what is the start index, end index, right? And difference, everything that we're mentioning. We'll just mid index, right? Nothing else. Maybe nums dot mid index, right? The number at mid index. Let's run and see. Oh, so this one is not running at all, right? So this has given us some idea that this is not running at all. Okay, and that's why we're getting output to be 0, because we have set it to 0 and it's skipping this entire thing and giving us 0. While difference is less than 0, we have written the what should have been was while difference is greater than 0, continue it. As soon as greater than 0, as soon as it reaches 1, just leave. Greater than 0, right? Greater than 0, yeah, that's what we want. If it is, if the array has got value, then we continue searching. If there is no values in the array, we exit this for while loop and simply return the start index. Okay, let's run and see now. All right, it's going forever and ever and ever. What have we done wrong is uh, the start index is 2, end index is 7, difference is 4, of course, mid index is 2. Okay, so what is happening at 2, 0, 1, 2, 3? right? What is happening at 3 is so if it is passing from here, it is going into the else if target greater than, yes it is, start index is equal to mid index plus 1. What is the mid index? Mid index is 2, 3. So we are going to look at 3, which is 4. Again, it should be like, oh, mid index, it's calculating to be a mid index, it's calculating to be method floor. Oh, that's creating a problem. Method floor is creating a problem. Is that so? What are we getting? Start index to be 3, right? And 7. Oh, 7 minus 3 is 4. 2. Mid index is not 2. Mid index is S start index plus mid index, right? No, no, no. Mid index is, yes, mid index is start index plus the difference divided by 2, right? Yeah, that's where we went wrong. So mid index is actually start index plus, right? So if we are discarding the first half and we need to find the mid index between the new starting point and ending point, it would be start index plus the difference divided by 2. So let's go about it now. Let's clear the console, run it, and there we have 0 1 2 3 4. All right, it's working fine. Let's copy this, what we have debugged. It's very difficult to debug something in because it's in Leetcode, because there's no console log data. You do get some here, but that's not sufficient. That's just not sufficient. Let's run this code and see, do we get correct one? Perfect, it is accepted. For smaller arrays, it would take longer time. If you can see, our runtime here was 76 ms, our runtime here is 100 ms. It's doing even worse than the average of this, right? So let's see what kind of a solution we get. So now we are getting into edge cases. The basic case we have solved. Now let's get into the edge cases. We'll just pull this down so we can look at the code completely. The edge case is input is 1356 and the output is 2, 0. Yeah, we need to remove this console log here. It won't work here. Output we are getting as 0. So what's happening is, let's dry run with this particular set and see what's actually happening here, right? So instead of R1356, we'll keep as 1356 1 comma 3 comma 5 comma 6, and the target is 2. Let's run and see what's happening. The console logged. So what's happening is start index is 0, end index is 3, of course, and the mid index is difference is 3. Okay, mid index is 1, of course, yes, this is the mid index. Nums at mid index is 3, of course, and 3 is greater than 2. So it's looking at the first half, it's discarding all this 3. It has now start index and end index to be the same, right? Oh, in this case it would be not s but s plus 1, right? Or am I wrong? In fact, it would depend on whether I am at the first half or the second half, right? If it is on the first half, it has come out to be start index plus 1, and if in case I say I pass in 7 here, right? 7 is not there, but I would reach at 6, okay? Then even that would be start index plus 1, right? Or end index plus 1. Doesn't make any sense. So let's try and run this one, right? So here it's giving me 4 for 7, and for 2 let's it should give me 1. Oh, absolutely right. So it's simply end index plus 1 or start index plus 1. That's the only thing we need to change to handle the edge case plus 1, right? Let's run the code. Perfect, working. Let's run the code for all the tests. All right, so that one clearly was done. There's a new edge case that we are getting 1356 and the target is 0 while we are getting 1. This is what I was hinting at. Okay, so it's returning e plus 1 while 0 is less than the largest, less than the start index, right? So I think it would be simply a little change here, conditional returning, right? So if nums at uh, start index, right, is less than target, okay, then return start index plus 1, else just return start index. I think that should work. Okay, and if I pass in 0 here now and run this test, it should give me 0. And if I pass in 2, let's see, 2, what do I get with 2? And we get 1, exactly what we wanted. So this is the only part that we need to change at the end, and that will cover our edge case for this one as well. So return nums at start index. If it is less than target, return s plus 1, else if it is not less than target, return s. Let's see, run the code. Working. Let's look with other tests, and it's working. It's working for all, right? 39.7 MB, that's the standard that goes into this, or 76 ms. All right, so this is great. This is great. So this is login solution. Why it's login solution? Because we are not looking at every number out there. We are discarding half of it with every iteration, right? Let's pull this down, see the entire code, and see how we can make this in a recursion format. Now we look at the recursion. This entire code, you may see that it is being repeated, right? Okay, and so what can be done? What can be done? What can be done? Let's rewrite the code. What can be done is, let's go here, let's rewrite the code. Let's just comment this one out, and we'll refer this one to get an idea, right, about how do we go about this in recursion format, right? So in recursion, what are we going to look at is there will be a condition, end condition, okay, and if uh, that is instead of nums, yeah. So what we'll be doing is instead of create a recursion function, right? Recursion is equal to function. This will take in start index, end index. This will take in nums, and this will take in target, right? It will take in these values, and it will start comparing. It will call let difference is equal to e minus s, okay. If diff is equal to 0, or basically less than 1, return. We did not find it. So what are we going to return? We're going to return this particular part, right? We're going to return nums at we're going to check if number at index start index is less than target, then we'll return s plus 1, else we'll return s, okay. If not, then we need to call the recursion, okay. Recursion will just what kind of recursion to be called, then we'll write this code, right? If we'll also calculate mid index before that, right? So we'll simply copy this part, okay. We'll copy this, we'll calculate mid index here. So this is also called as a base case, the one that we wrote, right? This is the base case. If number at mid index is equal to target, then we have already found it, right? So we just return mid index. We found it, we need not go recursing around, okay. But if not, then if target is greater than nums at mid index, right? If this is the condition, then we need to recurse. What we will recurse is we will make start index to be mid index plus 1, end index to be the same, right? And or we can remove this difference altogether. Why waste some memory here, right? That much memory because we are just using it for 2 cases here, right? And we are going to pass in nums, the reference to the array, the target value, okay. That's all. We'll just reduce this, right? And if that happens, else there'll be another recursion. This time else has got only one case, that if target is less than the number at mid index. So in that case, we'll pass in the start index as it is. We'll reduce the end index to be mid index minus 1. Okay, nums will pass in as it is. Okay, and if all that is done, okay, all that is done, we'll be returning from here. Whatever the response comes, will be returning from here, right? Yeah, so that's about it. That looks great. So we need to pass in, we need to delete all of this and call a recursion function. Okay, and we need to pass start index to be 0, end index to be nums dot length minus 1, nums and target, right? Let's run and see. At index 1, absolutely. Let's look for 0. At index 0, perfect. Let's look at 7. At index 4, perfect, absolutely perfect. Let's copy this part and put it in our Leetcode editor, and let's run and see. With the basic example first, we'll check if our code is working perfectly well. Now we'll see with the rest of the examples and see if this recursion worked. Recursion worked perfectly. So we first saw at the first way, we call it as the brute force method, where we are looking at every element, and with that we achieved the same result in order of n. Then we did some while looping. I'll just show you the solution here for while looping. We use this solution, okay, with the while loop, and we achieved the same solution with order of log n, right? And then finally we did it in the recursion format, so again in the order of log n, but in a recursive format. All right, that's it for today. Keep hitting like, keep sharing, keep subscribing. I'll be coming up with more such streams where we're live. For the first time I saw this question performed in front of you with 3 different solutions, and so you get a good idea, get good grip of how things are solved when you are in an interview. You need not learn every solution to every question. All you just need to do is to get an idea about how things are solved, and that's what I'm doing. So hit subscribe. See you then in the next one.